Why is there so much ice melting in the Arctic? This is a question I get asked quite often, because it seems like just yesterday, when we were all freaking out about the hole in the ozone layer and then that went away and now we were supposed to be freaking out about this. So what gives? Well, the answer to this question is more complicated than you think. It's not just one thing, but a number of things that are combining to cause this problem. But at its core, it all comes down to one thing, and that's an increase in temperature in the Arctic. And if you've been paying attention, you may have noticed that it's gotten a little bit warmer up there recently. And that's not surprising, because that's what's happening all over the world. Earth's average temperature is about 1 degree higher than it was 30 years ago. But that tiny change in average global temperature has had a massive impact on the Arctic. That's because even though the entire planet is warming up by only a couple degrees, the Arctic is warming up at twice the rate of the rest of the planet. So the Arctic is experiencing something closer to a 4 or 5 degree increase in temperature. And for places like Greece, that can be as high as 20 degrees Fahrenheit warmer than it was in the 80s. And that might not sound like a lot until you consider that water freezes at 32 degrees Fahrenheit. So in some parts of the Arctic, they're experiencing a 20-degree increase in temperature that's above freezing. No wonder the ice is melting. But again, why is that happening? Well, like I said, it all boils down to the greenhouse effect. The greenhouse effect is a natural process that makes Earth habitable, and not an ice cube. Here's how it works. When sunlight enters Earth's atmosphere, some of it's reflected back into space by clouds and other stuff in the atmosphere, but some of it passes through and reaches the surface where it is absorbed by the liquid water and turns it into heat. Then that heat is re-emitted in all directions. And if it happens to go upwards, some of it gets trapped in the atmosphere by the greenhouse gases and re-radiated back to Earth's surface. And that's why Earth isn't an ice cube. But humans burning fossil fuels have increased the concentration of greenhouse gases in the atmosphere by 50% since the Industrial Revolution. So now there is more greenhouse gases to trap that heat, and Earth's average temperature is slowly but surely going up. And that brings us back to the Arctic. Not only is Earth's overall temperature increasing, but the Arctic in particular is warming up faster than the rest of the planet, for 2 additional reasons. First off, as the climate gets warmer, there's less snow in the Arctic. Snow is great at reflecting sunlight back into space. So the less snow there is, the more sunlight's getting absorbed by the ocean and warming it up. Now, the second reason is a little more complicated. As the ocean around the Arctic warms up, it expands in volume. You see, when water freezes, it expands in volume and becomes less dense, so it sinks to the bottom. But when it starts to melt, it becomes more dense again and rises to the top. So warmer surface waters will be denser and sink to the bottom, while the less dense cold water will rise to the surface. Normally, this would be good for mixing up the water and kind of even out the temperature difference between the top and the bottom. But the Arctic Ocean has a bunch of really cold water at the bottom from all the ice. So cold that it's actually fresh water, unlike the top layer which is slightly salty. And that's important because salt water has a lower freezing point than fresh water. So that cold fresh water at the bottom doesn't mix with the warmer salty water on top. And it ends up just sitting there getting colder and colder while the warmer water keeps getting warmer and warmer. And that creates a stable stratification in the ocean with warm water on top and cold water on bottom, which prevents any mixing. So we have 3 separate processes all working together to cause the Arctic to warm up faster than the rest of the planet. The first is the increase in greenhouse gases that's warming up the entire planet, which in turn warms up the Arctic. The second is the loss of snow in the Arctic, which causes more sunlight to be absorbed by the ocean and warm it up. And the third is the stable stratification of the ocean that prevents the water from mixing and allows the Arctic waters to get even colder and the surface waters to get even warmer. And all of these processes are speeding up, meaning the Arctic is warming up at an accelerating rate. But wait, there's more. Another factor that's probably contributing to the recent increase in ice melt is a decline in the amount of light that's being reflected back into space by clouds and other particles in the atmosphere. That's because industrial pollution has increased the amount of aerosols in the atmosphere. And aerosols can either reflect sunlight back into space or absorb it and warm up the atmosphere depending on their composition. Aerosols made of sulfate, like the ones produced by volcanoes and burning fossil fuels, tend to reflect more light back into space and keep the planet cooler, while aerosols made of organic compounds like smoke tend to absorb more light and warm the planet up. Unfortunately, the types of aerosols produced by human activities tend to be the kind that warm the planet up instead of cool it down. And since aerosols typically only stay in the atmosphere for a few days before they either fall to the ground or get washed away by rain, they can have a significant impact on weather patterns over short periods of time. We don't know exactly how much aerosols are contributing to the rapid ice melt, but it's definitely a factor. But what does all this mean for us, poor saps stuck here on Earth? Well, as the ice melts, the Earth's average temperature is going to go up. So sea levels are going to rise and coastal communities are going to get inundated. But there's also another feedback loop that's going to come into play. As the ice melts, there's going to be less sunlight reflected back into space. So the Earth's going to get warmer, which means more. Ice is going to melt, which means even more sunlight will be absorbed, and the Earth will get even warmer, and the whole thing will just spiral out of control. Now, I know what you're thinking. If we just stop emitting carbon dioxide, then everything will go back to normal. Right? Wrong. Once you get past a certain threshold, the ice melt is irreversible. It's like if you let your house get too dirty, you could clean it up a little bit, but once you've broken that vase, it's too late. So even if we stopped emitting carbon dioxide today, the ice would continue to melt for centuries. So should we be freaking out? Well, it depends on how much you like polar bears. They're pretty cute, aren't they? Yeah, but don't worry. You can still watch them in zoos. Just kidding. They won't be in zoos, they'll be extinct, and that's why you should care. But not just for you or me. Climate change affects everyone and everything on this planet, including the freaking birds that live in our backyards.